So if I can minimize the surface area, that saves me a little bit of money on material, aluminum or tin or whatever it is that I'm trying to use. So I want to know what is the least amount of material I need to use to have a constant volume of 12. Do you understand the problem? Draw a picture.
Draw a picture.
And there's lots of possibilities. Right? For a cylinder, I mean, this is obviously bigger than a soda can, and holds obviously a lot more, but you get the idea. This has a radius in here. Now, if this was taller and thinner, it would still have the same volume, right? Or if it was fatter and smaller, it would also have the same volume. So there's many possibilities as far as different types of cylinders that we're going to run into. Keeping it a generic R and H is fine. Now, a soda can is going to have a top and a bottom as well, right? Let's talk about surface area. Let's talk about volume first. The volume of a cylinder. I put the formula up. Pi r squared h. Which is constant in this case? The volume or the surface area?
Volume.
The volume is. There we go. In Calc 3 we call this, well, Calc 3 we don't mind that there's two versions. Please figure out what the surface area is. You can do this. No, it's late. Piece this together.
Wait, surface area?
Well, I wrote the surface area. We take the area.
Not yet. Nope. You got to piece this together. I'll start. The top and the bottom are pi r squared, right?
Yeah.
And there's two of them.
Oh, okay, yes.
You get to get the body. Future problem solvers of the world.
Isn't it just height times plus height times
The whole thing. Yes.
Wait, how did you do circumference? Was it pi times diameter or was it pi times diameter?
What you come up with?
2 pi r?
That's right.
Yeah, that's the same thing as pi.
So picture this. Let's say, I'm just looking at the body of it now, right? Not the top and bottom, we already handled that.
Yeah.
So if I take it and I cut up and I lay it out, do you see it's a rectangle?
Yeah.
In fact, the rectangle will be
Sneaky.
still h. That's now 2 pi r, right? Circumference?
See, that's what I was trying to figure it out.
So this is going to be 2 pi r h. 2 pi r times h. The area. That's just the body part of it, right? Just this part, not the top and bottom. Top and bottom are here. Body part of it, there.
Is that why the r is only squared in the first part?
I can't do it.
Is that why the r is only squared in the first part?
Yes, this is actually two circles.
Right.
Area of the top, pi r squared, plus pi r squared.
Right.
Yes,
So you would get pi r squared multiplied by the area of that rectangle?
no. So this is 2 pi r. This is the circumference, the outside of it.
I understand how you're using those two to make that rectangle, but aside from that rectangle, you have the top and the bottom, so it would be 2 pi r squared times 2 for the top and the bottom, times that,
Plus,
plus that, okay.
because surface area plus surface area plus surface area, all the way around. Right, the body of it.
You're not trying to find the inside.
So that's volume. We already got that covered.
But, so if you multiply them, it would equal 12 ounces? For the optimal,
No. The volume is a constant 12 ounces.
okay.
So when you do that, you'll get 12 ounces no matter what R and H are.
Yeah, I'm trying to figure out how I
So let me just, I want to make sure I get through this.
Oh, I don't know.
So what I'm going to do is I'm going to rewrite this here. We're assuming that the radius is never going to be 0. If the radius is 0, then for sure the volume is 0. I'm now going to replace h with all this. That's all the same. I think. Yep. So down here, area is now a function of r only. Got rid of the h. And I need to take the derivative of the area because that's what I'm trying to optimize. After I take the derivative, then what?
You make it equal to 0?
Yes, because that's how we optimize it.
Mr. Ryan, why is it a negative?
Say again?
Why is it minus?
Because this is,
Oh.
Should it be the negative 24 DRBC or?
no, it's not a function of time in this case.
Oh.
Different kind of problem. So when maybe one comes down.
Mr. Ryan,
Yes.
in the book, it said the first derivative to be less than, greater or less than 0 based on
And he rewrites it as
maximize or minimize. Do I need to do that too?
Yeah.
The things in the book, in order to minimize, I need to set it
That makes sense. Thank
bigger
you.
than 0.
I think you're misreading it. So now I need to solve this equation. I'm going to multiply through by r squared. Remember, r is not equal to 0, so I can do that. Could you please give me a decimal approximation of that?
Okay.
Is that thing that's running off properly?
He changed it to RQ.
Right here?
Or yeah.
You multiply it. So he got rid of the denominator by multiplying the entire thing by r squared.
On YouTube.
Just raise that to exponents and he would eliminate that.
Now, if I want to find h, what do I do?
That's allowed.
Plug it into here, right?
I don't know.
Okay.
He said because it doesn't equal to 0. But I don't know.
I get you. No.
Say again. I'm not looking for the area, I'm looking for the dimension. Otherwise, yes. Yes, you can. Could someone please give me a decimal approximation of that?
Nope. Right? Too slow.
You notice about
They're double.
one's exactly twice the other one. We can actually use this process to prove that the minimum amount of material that needs to be used for any enclosed right cylinder. The dimensions are going to be where the diameter is exactly equal to the height.
Oh, nice. I think that's what you were looking for.
Diameter is twice that.
An identity.
Okay. So if the diameter is equal to the height, that's going to optimize that, that surface area. Now, most of you probably aren't old enough. Back in the day, when you would buy oil for your car, they came in these things called cans. Tin cans. And if you remember what they looked like, they really were a lot fatter and thinner. They were a little bit closer, a lot closer to the
Coffee
diameter
cans.
being the same as the height. Okay. Now, for a soda can, that's not going to be the case because I mean, not everybody can, you know, they want to make it a little bit more comfortable, so they don't optimize for that, which is why they changed from tin cans to aluminum cans.
Does the bevel at the bottom affect anything?
Just the way?
That's a,
Yeah, they got all the new stuff. Yeah,
that's a support issue for the
I was
aluminum.
going to say, does the
Aluminum's
carbonization
too
of the
thin.
liquid on the interior, I know it's a chemistry question, but like, does that
Volume.
affect the optimum? Oh,
It's just fine. Yes?
The last problem, the difference between X and Y is also.
Totally accidental. Totally coincidental.